Good morning, folks. This is the second lecture of week 11. And what we did on in the first lecture on Tuesday, we discussed uh, how to parameterize a solid part actually. Okay. And what I want to do today is to do the same thing, except that it's going to be in the context of an assembly. So in that product, there may be several parts that, based on the parameters that you define in your CATIA workspace, those parts will resize and act accordingly. Now, I also would like to impose some assembly constraints there, so that assembly constraints are respected when these things are also resized. Okay. Now, in order for you to be able to do this thing very efficiently, you should be able to display your parameters defined at the assembly level, first of all. Those parameters must be defined at the assembly level, and you must be able to display them in the tree. Now, it is different from how it was done for a part. For a part, remember that you went to Tools, Options, and then this thing pops up, and then for a part you went to infrastructure, part infrastructure, and the display tab. But we are dealing with an assembly. I want the parameters to appear at the bottom of the tree in the product tree. Okay, and that being the case, you have to go to, again, Tools, Options, Infrastructure, but the first item, namely product structure. When that happens, you take the very last tab on the right-hand side. So keep marching to the right until you reach tree visualization or customization. Make sure that these things are on. Okay, so in other words, activated. Or they should be all yes. I mean, two of them are related to what we are doing today. The other ones, you want to be there because if you want your material at the assembly level to pop up, I think, if I'm not mistaken, the first one, material and applications, and the other guy, what is that? Constraints probably are automatically on or yes. These two may not be yes, may not be saying yes if you're doing it. For example, today. Now, all right, so let's go ahead and do our first problem. The first problem is going to be something like that. So it's an outer piece and an inner piece, and I want this radius to be driving the model. Okay, so I want a single parameter in my tree, which is R, and when I change R, this resizes, so that this actually can fit into that. Okay, this is a warm-up problem, very simple. So what we're going to do is, first, let's go and make sure that our tree customization is active. So we go to Tools, remember, Options, and infrastructure, part infrastructure, and I went all the way to the right, or I'm going to go to the right, all the way to the right, tree customization, and these, I turn them on. And now remember, if you want to turn it off, you select it, you say deactivate. You see that? It becomes no. But I want to activate it. Activate. So I want all of these to be on. Specifically for today, right now, these two are critical for us. Otherwise, you won't be able to see the parameters. All right. So why don't we actually define a parameter just so that you can see. So you go at the very top. You know, you're at the assembly level. You click on f of x, and new parameter of type length. You click on it, and this is going to be R, and some value for it, for example, R1. Now, notice that there's nothing here because I haven't created anything. I haven't created anything in my product yet. That's why this is all pretty much blank, except for the parameter that I created. Now here we are. Notice that right there. Okay, now let's start making our part. So insert a new part in there, and I'm going to call this thing how about small, or let's say inner piece. How about that? So properties, we'll call it inner piece, okay? And same thing here, inner piece, okay? Let's make it. So you double click on the inner piece. On a convenient plane, on that horizontal plane, I will sketch a circle. I'll make a circle here. Okay, and give it a dimension because later on I want to do something to this dimension. Exit and pad it. So that's going to be the inner piece. Let's go all the way to the top. Insert, insert a new part. And I'm going to call it the outer piece. Outer piece. Outer piece. Okay, let's go make it. I'm going to double click on this. Am I important? Yeah. On that horizontal plane, I will sketch. Once again, a circle. Two concentric circles. Exit and pad it. Very good. So now we're going to go all the way to the top and click on f of x. Now, I want to set the radius of this circle, the inner piece, to be equal to r. So if notice that nothing is showing up. If I click on product, all the dimensions that we have defined will pop up. Okay. Now it didn't for this, but if you select on the outer piece, let me see now for a second. Maybe it was there. I didn't see it. Yeah, it is. Let me see. Let me turn this around. Oh, you know what? I did not dimension the outer piece. That's okay. No problem. So if you click on the inner piece, the dimensions associated with the inner piece pop up. If you dimension the outer piece, the dimensions associated with the outer piece pop up. And I think I forgot to dimension that inside radius. So cancel that. Let's go back to outer piece. I forgot to dimension that radius right there. Dimension it. That's one thing I forgot. If I don't dimension it, it's going to show up. It's not going to show up in that scheme. Okay, so we go all the way to the top. Okay. Let me minimize these so you can see it better. Okay, so click on f of x. Notice that if I dimension on the very top, all the dimensions that I've specified for this problem are going to pop up. Here is the radius of the inner piece. Here is the radius of the outer piece. And it's very simple because I'm going to select this is the inner piece radius right there. Add a formula equal to r, and we say OK. Notice that the reason it actually changes color because we just changed the radius. Whatever it was, now it's 1, but it has to be updated. Let's do the other one. Here is the outer piece. Add the formula equal to r. Both of them are going to be red. And then we say OK. And then if you update, they're going to be, this is going to be exactly the same size as that. Let's check it out. Let's make it 0.5. Update. Both of them are going to be the same size. That's very good. Now, I want to tell you that there are other ways of doing this. And to me, it's acceptable, but please make sure that basically you do it in a meaningful way. It is possible to select the radius of this and say it's equal to the radius of the outer piece, okay? And then use the radius of the outer piece as the parameter. I don't care how you do it, but either way. If you do it that way, one of the formulas that you get is saying this radius equal to that radius, and then the outer piece radius equal to r. It's up to you. Now, don't forget to put the assembly constraints here. So I want that to be fixed there. So anchor this. Coincidence between this axis and this axis, and coincidence between this plane and that plane. Okay, update. There we are. And if you, for example, say r equal to, I don't know, maybe 0.2, both of them will have radius 0.2. You can see that right there. So that was the warm-up problem. Let's get rid of this. Let's go to the next problem. All right. My second problem is very similar, except that I have more parameters. Okay. Now, on the next slide, I'm saying exactly what I just told you a minute ago, that it is possible to set an equation saying that, which has nothing to do with parameters, saying an equation which is this radius equal to that radius, okay? Or the radius here equal to that radius, and then use this guy as the parameter. But I'm not going to do it like that. I will actually create a parameter called RIP, like that, and use it, okay? So there is less chance of making a mistake that way, okay? So that is my problem, all right? So we need 1, 2, 3, 4, 5 parameters with these labels, and we're going to do the rest of the problem. So we go here. Let's start with the product. Okay. We can create our parameters now. You can do that later. It's entirely up to you. Let's do it now. Okay. So we go to f of x. Make sure you're at the top level. F of x. Of course, there's nowhere to be at the top level because there are no parts here. And let's create 5 parameters of type length. So first one, I'll call it, this is big radius of the outer piece. And let me make this thing 5. Okay, apply. Another one, little radius of the outer piece. Let's make that thing 2. That, okay, apply. Another one, big L outer piece. But it's a padded height. I'm assuming that they can be done independently of each other, so maybe 3. I don't even have to say apply. If I click on new parameter, it's going to be fine. Now, radius of the inner piece, the one that I said you can actually make an equation out of it, but here, let me make this thing, I don't know, maybe 0.5. And then another one, big L inner piece. That's the height of the inner piece, okay? And I'll make this thing 1. Okay. And then we say okay, and all our parameters appear here. Okay, now let's go make our parts. So insert a new part in there, and I'm going to call this thing the outer piece, OP. How about calling it OP? So properties, OP, basically it's a tube, right? So double click on it. Okay, so on a convenient plane, on that plane, I will sketch a circle and another circle. And we're going to dimension both of them. Remember, I forgot to dimension it last time. So here's one radius, here's the other radius, exit, and we pad it. Okay. And then I'm going to go all the way to the top, insert a new part in there, and I'm going to call this thing IP, inner piece, right click properties, IP, and IP. Okay. Let's make it. Double click on IP. On a convenient plane, on that same horizontal plane, I will sketch a circle. And this is just a circle. There's no cavity in it, so just like this, just like that. Okay, and exit and pad it. I will assemble it later on because it's easier to see the stuff on the screen and pick them than assembling and doing it. So I'll assemble it later on. So let me rotate this a little bit so that we have more room. I don't need these, so I'm going to collapse them. Okay, so make sure you're at the very top, very top, very top. Okay. And I'm sure you remember that when I wanted to create these parameters, I did that assembly. Do not do it at the part level because when we mark, we want to see these parameters down here. We go there and check, change, and things. I'm not going to go inside the part and trying to find what you have done. There will be definitely point deductions, and you don't want that. Okay, so you go to f of x. You click on the product. Anything you mention that you put on the product is going to pop up there. Okay, so for example, you want to say this guy is the radius of the inner piece. It's right there. Add the formula equal to radius of the inner piece. Fine. Now you select this guy. This is the inner radius. Which one is that? That's the inner radius of the outer piece. Okay. Add the formula. Inner radius of the outer piece. That is this guy. Okay. Add the formula. Okay. And then the other fellow, this other radius. Add the formula. This is the outer radius, the big R of outer piece. Okay, now the padded heights, let's see now. This fellow is for the outer piece. Add a formula equal to big L OP. And where's the other guy? Right there. That is, add the formula. So that is big L inner piece. And I think we have taken all the if I'm not mistaken, we should have 5 equations here. Hopefully you didn't make a mistake. You can always go and check. Double click on this thing. It'll take you to the equation editor and you can check it. But let's update. Where's the other guy? Oh, right there. So let's actually move these apart for a second. So let me move it in another direction. Y maybe? It's sitting there. Okay. Now, why do these things don't match? Because these numbers don't match. For example, if I want this to be perfectly matching that, the value, this value, or inner piece, must be the same as little or outer piece. So for example, look, if I make this thing 2, and this is 2, when I update, this is going to become exactly the same size. Height-wise, they're not the same. This size and that size are identical. Once I assemble it, you're going to see it better. Now, these are the heights. For example, here, let's say that the length of the outer piece is, I don't know, maybe 0.2. And length of the inner piece also 0.2. And update. They will be the same height. You can see that. Let's do some assembly constraints here. So let's anchor this guy. Okay. And coincidence between this plane and that plane. Let me cancel that. Let's say that the bottom of these two are flush. Okay, so coincidence between this plane and that plane. But the heights can be arbitrary, okay? Independently. I'm not insisting that this surface and this surface be flush, but coincidence between this axis and that axis. And update. There we are. Now, for example, you can say, okay, the inner piece, I want the height of it, or let's say outer piece, I want the height of it. Actually, let me say the inner piece, I want the height of it to be 1. Okay, it's going to be taller. Yeah, right there. If I want, for example, this radius of the outer piece, this guy to be bigger, so there we are. That is this distance, maybe 10. There we are. Okay, good. So that takes care of our other problem. Other problem being problem, this problem. So now I'm going to do this problem for you. Okay. All right. Again, I want to emphasize that there are different ways of doing these problems. However, this is how I'm going to show you. If you want to explore your own ways of doing things, I have no issue with it. Just make sure that when it comes to us marking your exam, we will go to the bottom of the tree, the very, very bottom of the tree. We see parameters at the assembly level. I change things from there, and the whole assembly must resize and fit together if assembly constraints are to be imposed, and you will be asked to impose assembly constraints if there are problems like that. Okay, so let's go ahead and do this problem. So we go here. Let me first go and start the product file. Okay, so I go here. What are the parameters that I need? I need beta, R, and these are H and H. So beta, R, H, and length, these two lengths, right? Yeah, LL. Eventually they will. So I need 4 parameters. 1, 2, 3, 4. Okay, so let's go ahead and do that. So just to convince you that the order doesn't matter, you can introduce your parameter at the very beginning or at the very end. The only advantage of doing it at the very beginning is that there's nowhere to go. Like, you don't accidentally create these parameters at the part level. But that's entirely up to you. It's entirely up to you. So we go to f of x. I'll do it right now. Parameter length. These are the pads. L. I'll make it 1. Another one. R. This is the radius of that circle. I'll make it, oh, I don't know, maybe 1. Another one. H, the size of the block on the 2 sides. I'll make it 6. Apply. Now the last one is your angle. So let me change this thing to angle and new parameter, and we will call it beta, right? Beta. And the value of it, I'll put down 45 degrees for now. Apply and OK. So we should have 4 parameters here, right there. And those match 1, 2, 3, and 4. Okay? So let's go ahead and make the yellow piece first. So insert a new part in there. And I will call this thing right-click properties yellow and yellow. Let's go make it. On a convenient plane, on that vertical plane, I will sketch. It's easy for me to make it a centered circle, centered block. Okay, good. Right now, it doesn't have to be a square, but later it will be a square, just to convince you. I'm going to put dimensions here, dimensions for this, and dimension for that. Okay, and let's go and try to do that other piece, that inner cavity. So let's go to the different ways of doing it. You do the way you want. So I'm going to do it like that. Okay. And then the rest of it, I'm going to do it with a polyline. This is going up, and this is coming to that location. Okay. Now dimension it. Dimension the stuff that we want. So this radius is going to be one of our parameters later on. And this angle from here to here is also going to be my beta. Whatever you do, this better be by the look of it. I mean, you think about it, when you have this angle specified, that radius specified, the entire shape is specified, and therefore everything must be white. I mean, if you go that route. Okay, I think that's pretty much it. Exit. And pad it. Okay. I'm going to change the color of this to yellow. Properties, change this thing to yellow. So now go all the way to the top. Insert a new part in there. No. And I'm going to call this thing the gray part. Actually, gray is great. Sorry. What I meant to say is that I'm going to call it gray part. So, how about inner part? Inner. Okay. Let's go make it. Double click on that, on a convenient plane, on that plane, same plane. We will sketch. I'll do exactly the same thing, so something like this. And polyline here. Obviously, this is going to be fitting that little cavity. And once again, I want to tell you that there are different ways of doing these things. Now, if I dimension this is going to be my radius later on. And this is going to be my angle. Okay, now notice that it is white, and the reason it's white is that I have to specify, if I wanted to make it fully constrained, the distance from this point to that origin. So let's try it. I don't need it, but I'm going to do that anyways. So from this point to that point, it should become all green. You can see that, okay? But I don't want. Good. Exit. All right, pad it. Okay. All right, very good. So now let us go and define our basically equations, right? So you go to f of x, make sure you're at the very top, very, very top, not here, because right now I'm in part. Any equation that I do is going to be put in this part. I don't want it. I want it to be in the part, in the product, right there. So you're in the assembly, right? Let me minimize these two because I don't need those. Okay, so f of x, there we are. If you click on the product, all the dimensions that you specified are going to show up. Unfortunately, because I made the color here, this turns out to be black, but that's okay. So let me start actually with the inside here. This angle, add a formula equal to beta. Okay, good. And this radius, add a formula equal to r. That takes care of this. Okay, now, if you want, we can say okay and update and just change the size. Okay, or you could have waited until the very end. So once again, you click on f of x. Now do the rest of the stuff. Okay, I already did these things. And notice that every time you create an equation, and you are creating an equation, these are the equations that you're creating, Katia calls it relations, it puts an f of x next to it. So it means that this guy is defined through an equation. But anyway, let's go ahead and see it. First of all, this top, let me start with the inside. This is beta add a formula equal to beta. And this is r. This is the radius here. Add a formula equal to r from 3. And this is h. Add a formula. And that is also h. That's the way we wanted it. Add a formula equal to h. Okay, I want this padded length to be L, that guy to be L. Add the formula equal to L. And where's the other guy? I forgot to do this one. And there is the padded length for this. I want them to be the same in this problem because it shows here these are both L. Add the formula equal to L. Okay. Now, before I put any assembly constraints, first I'm going to put them side by side here to see whether they actually look reasonable. Let's look at the normal view from the front. Right now, they're not the same size, but if I update, this better be able to fit there completely. And I think it does. Let's try some of the stuff. For example, let's take H to be 9. Of course, that will only affect this piece. Let's take R to be 2. It will affect both of them. There, you can see that. This angle, now if you put an unreasonable angle, if you put an angle less than, for example, if you put an angle equal to 20, it's going to come back and say, hey, you got a problem. You have self-intersecting curve. Let's check it out. 20. That's right. This is going to run into a problem because this sketch is self-intersecting. For the outer piece, the yellow piece, if you go to sketch, there, you see that? So let's go back and put, now, you can if you make h bigger, for example. So if you go back here, make it h equal to maybe 15 or 12 and update. It's still no good. Let's try it a different value. So how about 20? So something is still, something is checked. Let's check this sketch one more time. Ah, still there. Okay, so exit. No problem. Let's make h equal to 25. Update. I'm sure it's going to come back. There. Now, notice that there are no assembly constraints for the final exam. You shouldn't put assembly constraints here. I want these things to be fitting together. So let's go ahead and do that. So anchor the yellow piece and coincidence between, for example, this axis and this axis. Okay. And I think all I need to do, if I make axis to axis, all I need to do, for example, 1 point and 1 point here. As long as you do it so that it looks okay, that I have no problem. Update. Yeah. Okay, I'm sure if I rotate it do any crazy rotations here, for example, like this, like that, and update, they're going to go back to where they are. So we just finished this problem and we still have time. I want to do another problem. So my final problem is going to be parameterizing this assembly. So I'll call this thing the wedge and that thing the box, and the parameters are H, W, and beta, and L. Okay, this is supposed to be a cube, therefore every dimension is L. Okay, good. Let's go ahead and do that. There are many different ways of doing this problem. So here is the way I'm going to do that. Let's go up here. Let's get rid of all of this. I'm going to start with the product file. All right, so let me define my parameters first. F of x. Angle is going to be called beta, right? Beta. And for now, I'm going to make it 30 degrees. 30 degrees, okay. Apply. And now change this thing to length. Parameter of type length. It's going to be L. One of them, that's the size of the box. I'll make a 5, 6 here. Another one, W. W. And that W is this thing. I'll make it, for now, point, maybe make it 1. Oops, W. W make it 1. And also H, I'll make it 1 too. There's H. And make that thing also 1. Okay. I should have my 4 parameters here, right there. Now I'm going to make the box. So insert a new part in there. Call this thing a box. Right click properties, box. Put a cube if you want, and box. Okay, let's make it. Double click on that plane. I will sketch. I'll sketch a rectangle. Really doesn't matter, so I'll make a rectangle, centered rectangle. That's really irrelevant. Okay, I'm going to dimension. Dimension is because at the end of the day, this is going to become a cube, right? So we need those dimensions. So let's see now, dimension here. Right now it's 9, 8. Exit. And I'm going to pad it by about 8, 9 inches so that it gives us the image of that kind of box. Okay, good. Now, I will create on this face. I will draw a line. I will draw a line. Sure. On this face, I will draw a line, and the line goes like that. Let me exit. Make sure that this is what I want here. Yeah, on that face, that's correct. So this is in the YZ plane, right? Yeah. On the YZ plane. Yep. So I'm going to draw a line. We'll clean it up in just a minute. First of all, I want this point, control to be on that line. Hang in there. This point, control that line. Coincident. Okay. And I want this point also to be on that line. Just makes it easier. Control. Okay. Coincident. I want this distance to be W. I mean, later on to be W. Of course, right now I just want to dimension it. Dimension from this point to that point. This eventually becomes W. And this angle eventually becomes beta. So let me dimension beta 2. There. This eventually becomes beta. Exit. Fine. Now, I'm going to create a point over here, which is a distance h away. So the easiest way probably is to draw on that face. On that face. Draw a point. The point being there. Okay. A point. I want to put this thing on there. I don't think this is a good way of doing it. So let me try that. This point actually I don't need it. Let me go and the sketch. Let me delete it. Yeah. I don't like doing it this way. I'm going to create a point with a coordinate. Well, actually, let's do it on a curve, on a curve, on a curve. On this, which curve? This curve. But the other side. You see, reverse. I want this thing to be on that side. Okay, so let me see now. I think that will take care of. Yeah, I clicked on the reverse direction. So that point, that point is going to become eventually my H. Eventually, okay? So exit. Good. Now, I'm going to create a plane going from a point and a line. What is that? Point and line. There. The line is this. The point is that. Okay. Is that? Oh, that's normal. No, sorry. Cancel. Point and a line. That's what I meant. Point and a line. Point and through point and line. The point is here. The line is there. Okay. That's good. And I'm going to cut this, split it, split with this, and I'm going to select, keep the other side. There we are. Okay, good. Let's go all the way to the top. Now let's make a wedge. Insert, a new part. Could call it the wedge. Wedge. And wedge. Let's make it. So, for example, once again, on that vertical plane, I will sketch. Okay. Now, if any of these things are bothering you, you can always hide it. You can always hide it. So what I'm going to do is this. I'm going to hide that. I don't want to see it. And I'm going to draw my wedge. Okay. And the wedge, the way I'm going to do it is like this. So a line. Actually, let me make it polyline. Here to here to here to there. Okay. Dimension this because that's going to be W later on. This is going to be W. And dimension this angle. This is going to be beta. Exit. This may be an awkward way of doing it, but you see why. So I'm going to go and pad it more and more and more. Okay. Good. Now, on that face, let me see now. On that face, on this face, I'm going to create a point. On that edge, I'm going to create a point, just like I did before. So a point on a curve, on that curve, except that I want the origin to be on this side. So just say reverse direction. See that? There. This eventually is going to be equal to H. Say OK. And exactly like what I did before, create a plane through a point and a line. And the point is here. And the line is here. Say OK. And then split it. Split this with that. Which side do we want to keep? Is it this side? Well, let's see. If it's not the right side, I'll keep the other one. Yeah, that's good. That's good. That's good. Okay, so where's the thing that I hit? right here, box I hit. Okay, good, good. Now let me move these things apart. I'll go all the way to the top, all the way to the top. Move these apart. Move this apart. Move it in the X direction. I'll keep the other one in the same place. All right. Now we're ready to go. Go all the way to the top. F of X. You get the picture, right? You see where we're going with this. Click on the product so that all dimensions pop up. Let me collapse that. So let's find out. For example, this thing, see this thing is going to be my H. Look at the figure. H, okay? H. Add the formula equal to H. Yeah, add the formula equal to H. Good, good. Now, I want the beta and W, and that is appearing in a sketch. So let's go to the wedge and click on the remember I made a sketch here on this sketch. Let me show it right there. You can see that. You can see that it's right there. Okay. So if I click on the wedge, the dimensions of that guy should appear somewhere. I thought I dimensioned it, did I not? Remember I called this thing beta? Let me see on the pad is okay. That angle, well, we can find it from here. This angle wedge, there was an angle right there. This is the angle, right? Oh yeah, right there. I want this thing to add a formula, be equal to beta, beta, say okay, good. And that dimension, that dimension, actually the dimensions are appearing on this, so I didn't have to go through this list. It was also to the right of it, you can see that. And where is that distance? If you look at the, hang in there. Okay, that's good. What I want is that H. Remember that parameter H? So that was in the wedge, right? That was in the point right there. And that thing is, oh, we already did that. I think we already did that. It's the W that I wanted to do. Okay, I missed it. There's the W. This is W. Add a formula equal to W. Where's the W? Here. Say okay. I have done all the stuff that I needed for this wedge. So let's go check it before we do the same thing to that guy. So update. Okay, see. There we are, right there. These numbers are too small. So let's make W equal to 5, 6, and H equal to 8. Okay. And angle beta, we keep it the way it is, no problem. Right there. Okay, very good, good, good. So obviously this is working, and I can check with beta if I make it 45, for example. Yeah, so that is working. Now I have to go and do the same thing to the box. So f of x, click on, let me click on the whole thing. Okay. So first of all, this is add a formula equal to L, right? L. The only thing is that because of these size, oh yeah, okay, L. Okay, fine. I'll do that at the end. Well, That's okay, no problem. Let me for now say there will be a problem because of that H value. Let's see, apply. Let's check it out. Okay, okay. You know what I'm going to do? I'm going to make that H smaller, maybe 4, because I made this thing 6. So make H 3, and W also 3. Of course, the 3 size is the other part, and that's okay. Resize that. Okay, so let's go back here. F of X. All right, click on the product. Okay. Already did this. And where's the other dimension that way? The other dimension that way is right there. Add the formula equal to also L. And the padded length is here. I made it 9. I want also that thing to be add the formula equal to L. Let's check, make sure everything's okay. Update. Good, good, good. That's pretty good. Now let's go back to F of X. Okay, and click on the product. Let's see now. Where is my angle beta? This is the angle beta. And this is coming from the box, right? Notice that. Add the formula equal to beta. Okay. And this guy was the location that I chose for this point. So selected that. This should be add a formula equal to H. Okay. And this is your W on that box. Add a formula equal to W. I have a feeling that we got everything done. Okay. Update. Yeah. Okay. Very good. Now, what we can do is, first of all, I don't want to see these sketches. These are all getting in my way. You know how to get rid of these things. So you go to, well, you can do it from the tree. This, control that, shift that. Hide. Okay. Do the same thing for the box. This, shift that, hide. There were 2 other planes here. One here that I use, hide, hide. There's the sketch, hide. Okay, there's this point, hide. There's this sketch, hide. Point, hide. Okay, let's put these things together. First of all, it's easy to see whether it's working or not. So anchor that guy. Coincidence between this face and this face. Coincidence between this face and that face. And coincidence between this face and this face. Maybe overdoing it, but we'll see. Okay, now let's go and change our stuff. So beta is this angle. So let's make that thing 30. Update. There we are. They're both. If you don't believe me, just do the wireframe. You can see that they match, right? Put it back. What about W? W is this length. So let's make this thing 5. I mean, obviously, if you put a ridiculous number there, the sketches are going to be self-intersecting, etc. H is going to be this length. So we're going to 1. And there we are. It's working. I consider this the harder of the 3 problems or 4 problems that I've done. But hey,